This is Nathan Smith continuing to discuss homework 3 for my classes in Visalia in North Fresno. So, problem 7.2 in the text was from table 7.1, construct a table similar to table 7.2 showing the total marginal product, total product, marginal product, and average product of labor, as well as the output elasticity of labor when capital is kept constant at 4 units rather than 1 unit. So again, can't remember if we might have gone over this, but we start from this table. No. We start from this table. Capital is 4 units. We copy those numbers into this column, and then average product, you just divide total product by the labor supply. Marginal product, see the change divided by the change in labor, which in this case it's always stepping up by 1. Output elasticity is marginal product over average product. And then when I make charts, you get total product here, average cost and marginal cost. That's just mapping all the stuff. You notice that marginal cost in this case goes below 0. But these results differ from those in table 7.2 in the text just because there's a little more capital, so the curve goes up considerably higher, and diminishing returns don't sit in as fast. Okay, so then 7.4, this is where we talk about Mrs. Smith, and the owner of all of the clear duplicating service. And what I've done here, so this is Miss Smith, clear duplicating service. Let's add in another line here just to make this a little clearer. So this is L all along here. And so this, as you hire more workers, labor goes up, of course. Total product keeps rising, but it rises at a diminishing rate. Marginal product keeps falling. Marginal revenue product, notice that my formula here, it's just marginal product times 10, because that was the specification of the problem. They said each unit, price of each unit is $10. So she's not facing a downward sloping demand curve. She's not facing a problem with exhausting the market and having to lower her prices to move more product. So marginal cost is 40. It's always the same. That's how much the worker costs. So to maximize profits, you want to look for the place where the marginal revenue product and the marginal cost are the same. If you notice, for the fourth worker, then you make $20. You make $60 of revenues, and then you have to pay out $40 in profit. It gives you $20 net increase in profit at $20 increase in profit for hiring the fourth worker. The fifth worker gives you nothing, 0. So, I mean, you don't lose money, but you don't gain anything either. So, whether you want to hire him or not, it's kind of arbitrary one way or the other. 4 or 5, as far as I'm concerned, are equally correct answers. But it's definitely one of those two, and you also want to understand why. Okay, so that's it with the rest of chapter 7. Now, moving to chapter 8, we begin with problem number 2. So we get the total cost schedule of a firm. That's here. So then we're asked to, first of all, derive the total fixed cost and total variable cost, and then the average fixed cost, average variable cost, average total cost, and marginal cost. So we can get all of these things, 1, 2, 3, 4, 5, 6 different variables, all from total cost. For total fixed cost, that's clear, when quantity is 0, you're still spending money. That's fixed cost. No matter how much you reduce your production, apparently you always incur those, and that's the same. It stays the same over the whole range of quantities of labor that you might choose to hire. Okay, total variable cost, well, this is just all variable costs are the costs that get added on as you change the scale of your production. So it's just everything minus the fixed cost. So you notice the formula I used equals total cost minus total fixed cost. Okay, now average fixed cost, total cost divided by quantity. Average variable cost, total variable cost divided by quantity. Average total cost divided by quantity. Sorry, I can't remember if I said this right. Average fixed cost is fixed cost divided by quantity. So basically these are the same things, you just divide them all by quantity to get these three values. And finally, marginal cost. Marginal cost is total cost minus total cost for one less of quantity. So here we're comparing different rows. You know, you're stepping back to zero labor and how much would your cost be, and then if you raise it up to 1, if you raise it up to 2, sorry, 0 quantity, that's what your cost would be. If you raise it up to 1, that's your quantity. And then, so marginal cost is just the difference between each value of total cost and the one at the previous step. It's how much is added to total cost when you expand quantity by that amount. So those are the numbers, and the curves are charted here. Should just derive from these curves. And yeah, probably I desire more labels and stuff like that. That would be better. But I'm making up for it with an explanation instead. And so here's my quick jottings just to resolve this question about the airlines. So this is the airline problem. So there's fixed cost, there's an evening flight. This is where the airline is currently running this evening flight. And these are the variable costs, and notice when I break this down I add 11,000, that's the operating cost, plus 1,200, that's the cost of staying overnight in New York. So morning flight, the airline is considering running this flight instead, and they'd make lower profits, but they'd also incur less costs. Basically, they make lower profits because they get about 10 less passengers, but they incur lower costs because they don't have to leave the plane overnight in New York. So the return flight, no questions about how that's going to be done, and they earn $10,000 on that, incur $11,000 in variable cost. So, business plan with the evening flight, what we do is we basically take everything in, well, most things in that list get added up somewhere, except for the morning flight one. So we say B3, evening flight revenue, plus the return flight revenue, B7, minus all your costs. So we're calculating profits, that means we're calculating revenues minus costs. So the revenues from the two flights minus the fixed cost, the variable cost associated with the evening flight, and the variable cost associated with the return flight. Okay, so for the morning flight, now it's the morning flight revenue plus the return flight revenue, minus the fixed cost, minus the variable cost of the return flight, minus the variable cost of the morning flight. And you notice the airline loses money either way, so the airline should not stay in business. And if it were to stay in business, it would be better off sticking with the evening flight. It loses less money that way than it does with the morning flight. So, that's homework number 3.